Hello everybody. Once again I am here with you for the another unit or the topic related with the paper number our 15, digital and communication electronics. Basically we will learn in this unit that is called to be logic gates, the unit number 2. uh, Basically whatever be the data is going to be converted, it is in the digital form. Whatever be the CPUs or the any software hardwares can be uh, used for the understanding the data, that is zeros and one only. That is the binary numbers are going to be used for the any digital circuitry. And to get converted this type of the data into this digital form, these logic gates are to be very much important. And using this, that can be transferred. And another very important thing, as far as the basic gates are basically the logic gates are going to be concerned, the whatever be the understanding is to be with the binary number system is to be there. And where we are aware about that, the binary number system is nothing but to be only containing two digits, and that is the 0 and the 1 is to be there. And this signal, that is to be as an 0 or 1, it is to be given in the form of either there is no signal or there is 5 volt voltage is to be there, and that will be with the form of LED glowing to be on or off. When it is to be off, then it is to be 0. When it is to be on, then it is to be 1. So in this format, the whatever be the signal is going to be considered in this 0 and 1 format. So to get this understanding this term, that is the what is meaning to be as an logic gates, the simply the gate is to be the gate with what we have for our day to day in day to day life. For the any house or the home, there is a gate, and we allows the people only whom we known to them. That means the gate will be open if the person is to known to you, and then again it is going to be closed. In simple way, that is to be gate is going to be on or off for any condition is going to be satisfied, then and then the gate is going to be open, otherwise it is off. The same thing is to be there for the logic gates. When the condition is going to be satisfied for the any given basically condition, when the condition is going to be satisfied, then the gate will be on, otherwise it will be off. The another example is to be there, if suppose you wants to be as an admitted, if you wants to admission in any colleges, you need at the BSc first year classes, then you have to be with you as an your TC is compulsory original to get admitted in that college. And for this condition, when the your condition is going to be satisfied, then and then only your admission is going to be confirmed. So this is what the gate is going to be open or gate is going to be off. So for the logic gates, for that there are different types of the many gates, and for these different gates the logics are going to be different. And we start with this first case, what is called to be as an basic gates. So these are the very important basic gates, what because with these basic gates, whole the logical gates are to be dependent. And that's why these basic gates or the fundamental gates are having the importance in this logic circuitry. So beginning with the very simple and familiar to our behavior, that is the NOT gate, or it is also called to be as a your inverter gate is to be there. So NOT gate is simply is nothing but to be doing complement whatever the input is given to this gate. So this is one input gate, and it is also called to be as an inverter gate, or the which is also called to be as an complementary gate, or the whatever the signal input is given, that it will gives you output as a reverse to it. Means if suppose the A is to be as an input suppose given for the in that circuitry, and the or that say gate not gate, then it will gives you reverse complement of whatever be the A as an output. That means if suppose you are giving input as a 0, it will give output as a 1. If you are giving input as a 1, it will give output as a 0. So it will be in this case complement output it gives, or the inverted output it gives, and that's why it is called to be as a NOT gate. And another basically, if you want to learn about this NOT gate, that is the symbolical representation. If you look at this It is simply to be as an one diode type of the thing, but there is a bubble that gives you nothing but to be indication for the NOT gate is to be there. And as I told you, if suppose the 0 is the input is given, it will give you complement of that input, that is the 1. And when the 1 input is given, it will give the complement of that 1 is to be 0. So in this case, the truth table gives you the information because there is only one input, it is only having the one output. In that cases are to be there, it only inverting or the complementing whatever the input you have given, and that's why it is called to be as a NOT gate. As far as symbolic representation is to be there, it is just like this. The another basic gate which is also to be very important, and that is called your OR gate. OR gate simply also it is called as a addition, or the addition of the any two digits are to be there. How it is called to be as an OR gate is to be as an addition or likewise to be there. So minimum there are n number of input gate is to be there, but if suppose there are two inputs are to be there, and if suppose it is called to be as an A and B are the two inputs, variable inputs are to be there, then probabilities of inputs for these two inputs will be 4. That means both will be 0 0, one will be 0, another will be 1, first will be 1, another will be 0, both will be high. So it is 0 means low and 1 means high, also it is to be there. Somewhere it is in operator, it is also called to be as an true and false is to be there, true for the 1 and false for the 0. And this is what the again 0 for the low and 1 for the high is to be there. So when the two inputs are there, probabilities of inputs are there, for 4 probabilities are to be there. Both will be 0, both will be low, both will be high, both will be 1. One of them will be low or high, that is to be two conditions are to be there. And so according to that means for the this type of the OR gate, the what you have the output, the truth output, that truth table clearly indicating. As I told you, there are two inputs are there, minimum n number of input gate is to be there. 0 to 1000 inputs you can give to this type of the gate, but basically we are looking for minimum two inputs are to be there. It will never be a single input gate, it is minimum having the two input gates are two inputs are there for this type of the gate is to be there. When two inputs are we are considering, the probabilities of inputs are becoming to be 4. And for this case 0 0 will give you 0, 0 1 will it will give you 1, 1 0 will it will give you 1, 1 1 will give you it is to be as an 1. So if you look at this case, it is simply nothing but to be giving you addition thing is to be there, 0 0 that is 0, 0 1 that is 1, 1 0 that is 1, 1 1 that is to be 1 0, or it is result is to be as an 1 consider. So if you look at any of the input is becoming to be high, then the output is becoming your high is to be there. So the logic behind this OR gate is clearly indicating when any of the input is to be 1, that is high, output is high, otherwise it is 0. So if suppose n number of inputs are to be there, that is supposed to be 1000 inputs are to be there, and when these 1000 inputs, out of these 1999 inputs are the supposed to be 0, and only one is supposed to be having the high, so in that case the output will be high. Why it is to be there? Because either 999 are 0, but the one input is high. And what is the logic behind this OR gate? Any of the input is high, output will be high. That is why the output will be high, otherwise it is to be 0. So this is what the case where to be this OR gate is going to be working. So symbolic representation, if you look at for this gate, it is just like this. And if you look at this, it is some sort of giving you addition, and that is 0 plus 0, that is 0, 0 plus 1, that is 1, 1 plus 0, that is 1, 1 plus 1, that is 1 is to be there. So this is what the case where we have the output as an addition, and that's why it is called to be as an also addition, or the OR gate is to be there. So we have seen how it is symbolically represented and what is the logic behind this OR gate. There is another one gate that is called to be as an AND gate is to be there. So AND gate, it is some sort of called as a multiplier, or the multiple case is to be there. So in this case, this AND gate, it is again n number of inputs are to be there given, but the output is going to be only one. And n number of input, that means 0 to 1000 inputs will be there, but the what happens, minimum inputs will be 2. And according to that, if suppose we are looking for what will happen for this such type of the AND gate, symbolical representation for this AND gate is nothing but to be half semi-square like of this. There are minimum 2 inputs are there, and whenever the minimum 2 inputs are there, the probabilities of the input will become to be as an 4, that is 0 0 0 1 1 0 1 1 is to be there. The possibilities or the input number of inputs are to be 4. म्हणजे मिनिमम 4 पद्धतीचे इनपुट्स त्याच्यामध्ये असू शकतात. जेव्हा 2 इनपुट आपण कन्सिडर करायलो आहेत त्याला मिनिमम एक इनपुट कधीच नसतं, त्याला मिनिमम 2 इनपुट असतात. मग 2 इनपुट असतील तर इनपुट वेगवेगळे असण्याच्या कंडिशन्स किती असू शकतात, 4. एक तर दोन्ही 0 असेल, एक तर दोन्ही 1 असेल, एका पहिला 0 असेल, दुसरा 1 असेल, पहिला 1 असेल, दुसरा 0 असेल. दॅट इज लो और हाय केस इज टू बी देअर. So these are the 4 input probabilities are to be there. So in this case, it will give you this AND gate output as a 0 0 0 0 1 0 1 0 0 and 1 1 1. So if you look at this case, where the 0 into 0, it is to be always 0, 0 into 1, it is always 0, 1 into 0, it is always to be 0, 1 into 1, it is always to be 1. So it looks like to be as a multiplier. That's why this AND gate is also called to be as a multiplier in that case. So what is the logic in this case if suppose this AND gate is to be there? If you look at carefully, when all the inputs are high, the output is giving you high, otherwise it is all outputs are 0. So what is the logic behind this AND gate? When all the inputs are high, then and then only output is to be high. What was it is logic behind that OR gate? Any of the input is to be high, output is to be high. But for the AND gate, the condition is to be when all the inputs are high, then and then only output will be high. And if suppose n number of inputs, that means 1000 inputs are there instead of these two. And if suppose this 999 are to be high, and this 1001 is to be 0. So 999 inputs are 1, but the only 1 is to be 0. So in that case, what will be the output for the such type of the case? That the output will be 0. Why it is to be the 0? Because the condition for the AND gate is that when all the inputs are high, then and then only the output will be high, otherwise it is 0. And that's why this logic behind this AND gate is nothing but to be when all the inputs are high, output is to be high. This is what the symbolical representation for this AND gate, and it is denoted with the dot, that is y is equal to a dot b is to be there. So this is what the symbolical representation for the AND gate is to be there. So what we have learned? We have learned the basic gates, that is the one is to be NOT gate, which is called to be as an complementary. Whatever the input is to be there, it is one input gate and one output is to be there. When the 0 is to be input, output will be 1, and the 1 will be input, output will be 0. So it works as an inverter or the complementer, or that's why it is called to be NOT gate. OR gate is to be having the logic that any of the input is high, output is to be high. And as far as the AND gate is to be there, the logic behind this AND gate is to be there when all the inputs are high, the output will be high. So this is what the case where all the three basic gates are to be fundamental gates. With these basic gates, there are another gates are to be modified or created, and that's why these basic gates are having importance in these logic circuits. And thank you for again joining this session. Be at home and be safe. Thank you.